All of these substances cannot conduct electricity in solid state. Can you identify which of these substances is an electrolyte and which of these are non-electrolytes? Click on the substance.
Electrolytic cell. This is an example of electrolytic cell. What is an electrolytic cell? It is one type of electrochemical cell. In electrolytic cell, electric current is applied externally. This will cause a non-spontaneous chemical reaction in electrolytes. Allow me to show you how to set up this electrolytic cell for molten electrolyte. To set up an electrolytic cell, you need 2D batteries, 2 carbon rods with holder, an ammeter, wires with crocodile clips, crucible, tripod stand, pipe clay triangle, and Bunsen burner. Now watch closely how I fix the setup. Now, look closely at these carbon rods. In this setup, each carbon rod has their own name. Do you know what they are called? Both carbon rods are electrodes. The one attaches to negative terminal of a battery is called cathode, and the one attached to positive terminal of a battery is called anode. Now we are ready to carry out our investigation on electrolysis lead to bromide. Now, record your observation. Fill in the observation table. Press Enter when you are done. In solid state, ions that make up lead-2 bromides are fixed in positions. They are not freely moving. When heated up, the molecules vibrate vigorously. As the temperature reaches the melting point, lead-2 bromides slowly dissolve and melt. At this point, the ions dissociate and move freely. When the switch is closed, electric current passes through the ions. Negatively charged ions, or anions, that is bromide ions, move towards anode. And at the same time, the positively charged ions or cations, that is lead-2 ions, move toward cathode. Click on the anode and cathode button for a close-up view. At the anode, each bromide ion is discharged. Each bromide ion will release one electron to anode to form bromine atom. 2 bromine atoms combine to form a bromine molecule. Hence, bromine gas evolves at the anode. At the cathode, each Lead-2 ions accept 2 electrons to form a lead atom. Hence, silvery grey globules can be seen at the cathode. Let's revise what happens to molten Lead-2 bromides, one step at a time. Key in your response in the table given. Write down the formulae for ions present in molten Lead-2 bromides. Press Enter when you are done.
Try again.
Write the formulae for ions moving toward anode and cathode. Press Enter when you are done.
Try again.
At the anode, what happens to bromide ion? Does bromide ion release or accept electrons? How many electrons? Press Enter when you are done.
Try again.
At the cathode, what happens to Lead-2 ions? Does Lead-2 ion release or accept electrons? How many electrons? Press Enter when you are done.
Try again.
What can be seen at the anode and cathode? Press Enter when you are done.
Try again.
Click on the next button to continue. Now, let's test your understanding. Observe the electrolysis of molten 2 iodide. Then, fill in the analysis table and press Enter when you are done.